Imagine being the most powerful ruler in Europe and hosting an elaborate dinner party where you want to show off your absolute wealth and status to the most influential people of your time. You do not bring out the heavy gold plates that have been the standard of royalty for centuries. You do not bring out the intricate silver spoons that usually signal the height of luxury. Instead, you present your most prestigious guests with cutlery made of a mysterious, lightweight, silvery metal that costs more than any gemstone or precious metal held in your vast treasury. This was the strange reality in the middle of the 19th century. Aluminum was the ultimate status symbol, a metal so rare and so incredibly difficult to produce that it was kept in museum cases and worn as fine jewelry by queens. Today, we wrap our leftovers in it and throw it in the bin without a second thought, treating it as one of the most disposable substances in our kitchens. This is the story of how one of the rarest substances on Earth became the most common, and how a literal race to unlock its secrets changed the physical weight of our entire world.
Before the 1880s, the world was a fundamentally heavy place. If you wanted to build something strong, you were limited to the materials that had defined human civilization for thousands of years. You used stone, brick, or iron. If you wanted something that could withstand the elements and the passage of time, you looked toward bronze or lead. These materials were reliable and sturdy, but they were also incredibly dense and difficult to move. The dream of a metal that possessed the strength of steel but felt as light as a feather seemed like something out of a fairy tale or a work of early science fiction. Scientists of the era knew that such a metal existed. In fact, they knew it was everywhere. Aluminum is actually the most abundant metal in the entire crust of the Earth. It is hidden in the common red clay under your feet and the rugged rocks in the hills. But for most of history, it remained trapped. Unlike gold or silver, which can sometimes be found in pure, gleaming nuggets in a riverbed, aluminum is chemically stubborn. It bonds so tightly to oxygen and other elements that prying it loose required a massive amount of energy and expensive, dangerous chemical reactions that were far beyond the reach of early industry. The process of obtaining even a tiny bit of pure aluminum in the early 1800s was a logistical and scientific nightmare. It involved using volatile chemicals like potassium and sodium. Because these chemical agents were themselves hard to produce and dangerous to handle, the cost of refined aluminum remained higher than the cost of gold. It was a laboratory curiosity. It was a plaything for the elite who could afford to commission small pieces of art or jewelry from it. People looked at the gleaming silver-white surface of the metal and saw a future of lightweight machines and shining cities, but they had no practical way to get there. The bottleneck was not a lack of material because the mountains were full of it, but rather a lack of a cheap and efficient way to break the chemical bonds that held the metal hostage. The world was waiting for a spark of insight that could turn a royal luxury into a common commodity. That spark finally arrived in 1886, and it came from two different places at the exact same time. On one side of the Atlantic, a young American chemist was working tirelessly in a modest shed behind his family home. On the other side of the ocean, a young French inventor was conducting his own intense experiments. Both men were in their early 20s. Both were completely obsessed with the exact same scientific problem, and both arrived at the identical solution within weeks of each other. This stands as one of the most famous and striking examples of simultaneous discovery in the entire history of science. They realized that the key to unlocking aluminum was not through more violent or complex chemical reactions, but through the invisible power of electricity. The idea was to dissolve a form of aluminum ore in a molten mineral bath, and then run a powerful electric current through the liquid. This process would pull the aluminum atoms away from the oxygen atoms and allow the pure, molten metal to settle at the very bottom of the container, where it could be collected. It sounds relatively simple to us now, but at the time, it was a total revolution. It bypassed the need for expensive chemical reagents and replaced Rome with a force that was just beginning to change the world in other ways. This method, which we still use today, completely shattered the price barrier that had kept the metal in palaces. Suddenly, the metal that had cost more than gold was becoming something that could be produced by the ton in large industrial facilities. However, having a great idea in a lonely lab or a backyard shed is not the same as changing the entire world. To make aluminum a global reality, these inventors and the entrepreneurs who followed them needed a massive amount of power. This is where the story of aluminum connects directly to the rise of the modern industrial system and the harnessing of nature. The process required so much electricity that it could not just happen anywhere. It needed to be situated near massive, consistent sources of energy. This necessity drove the development of huge hydroelectric projects that transformed the landscape. Factories began to sprout up near massive waterfalls and great rivers, using the rushing water to generate the constant current needed to feed the hungry electrolytic cells. This was the beginning of the era of scale, where the size of the factory and the amount of power available dictated the success of the industry. As the production grew and the factories multiplied, the price of the metal began a spectacular and rapid tumble. In a matter of a few short decades, it went from being sold by the ounce in jewelry shops to being sold by the ton to manufacturers. But the industry faced a new and unexpected problem. Now that they could make all this aluminum, what was it actually meant for? People were used to the comforting weight of iron and the familiarity of wood. They had to be convinced that this new, lightweight material was trustworthy and capable of doing real work. The race to produce the metal quickly turned into a race to find uses for it in everyday life. Early marketing efforts were incredibly creative. They made everything from common tea kettles and delicate surgical instruments to the cap on top of a famous monument. They wanted to prove to the public that aluminum was clean, it did not rust like iron, and it was light enough for anyone to handle without effort. By the turn of the century and into the early 1900s, the timing of the aluminum boom lined up perfectly with another technological dream that was taking hold of the human imagination: human flight. You cannot build a practical airplane out of heavy cast iron or dense lead. The early pioneers of aviation were desperate for material that offered a high strength-to-weight ratio. When the Wright brothers were building their first successful flyer, they could not find an engine light enough for their needs among the existing options. So they did something radical for the time and had an engine block custom cast out of an aluminum alloy. It was a turning point for the entire species. Without the ability to produce lightweight materials at a massive scale, the history of aviation would have looked very different and progressed much more slowly. The sky was no longer the limit, because we finally had a material that belonged in the air. As we moved into the 1920s and 30s, the influence of aluminum began to seep into every corner of human life. It changed the way we built our cities and envisioned our architecture. Because aluminum is resistant to corrosion and remarkably easy to shape, architects began using it for window frames, decorative panels, and the structural skeletons of the first true skyscrapers. It allowed buildings to go higher than ever before without the crushing weight of traditional materials like stone and brick. In the world of transportation, cars and trains started to shed their heavy iron skins in favor of aluminum components. A lighter vehicle required less fuel and could move much faster, changing the very nature of distance and travel. The economics of the entire world were being rewritten by a metal that had been a royal luxury only 2 generations prior. The story of the aluminum race also highlights the shift toward global standards and massive industrial systems. This was not just about 2 young men with a good idea. It was about the creation of a complex global supply chain. You needed bauxite mines in one part of the world, specialized minerals from another, and massive power plants somewhere else. It required a level of international coordination and investment
that defined the early 20th century. It turned material science into a cornerstone of the global economy. The race changed who won and who lost in the industrial landscape, creating massive new corporations and shifting the focus of all manufacturing toward efficiency and lightness. Today, we are surrounded by the legacy of that 1880s breakthrough. When you look at a modern smartphone, the frame is often a precision-engineered aluminum alloy that feels solid yet light in your hand. When you see a massive airliner crossing the ocean, you are looking at several tons of aluminum held together by the same principles discovered in that shed and that lab over 100 years ago. We are currently in a new phase of this journey as we look toward electric vehicles and sustainable energy. The demand for lightweight materials is higher than ever because every pound saved in a car's frame is more range for its battery. We are still obsessed with the same goals that drove the pioneers of the 1880s: how to make our world stronger, lighter, and more efficient. We also have a different perspective on the metal now than they did back then. We have learned that while aluminum takes a massive amount of energy to produce the very first time, it is incredibly easy to recycle. It is one of the few materials that can be melted down and reused over and over again without ever losing its fundamental properties. This has turned it into a vital part of the modern conversation about a circular economy and environmental responsibility. The metal that was once more precious than gold is now a key to a more sustainable future. Looking back, the race to unlock aluminum was not just about a single material. It was about proving that we could take the most common elements of our planet and, through the power of science and industry, turn them into the building blocks of a completely new way of life. And that is how the race for aluminum smelting and lightweight materials turned a royal luxury into the invisible backbone of our modern world. Next, we move forward in the timeline to 1888 to see how the next breakthrough in photography changed the stakes for everyone. If you enjoyed this journey through material history, subscribe to catch the next episode. We will see you there as we explore how photography moved from the daguerreotype to roll film and put the power of the image into the hands of the masses.